think I've got the screen figured out, so let me fire that up. And presentation HTML is about to appear.
Show something.
Yeah.
Yes.
Oh wait, that still doesn't fit.
Yeah.
Oh, that now it fits. Perfect. Cool. Whoops. You'll have to forgive me being clumsy around GNOME. I haven't used it in a while. Okay, welcome everyone. So today we're going to chat about building a self-contained zero-dependency deployment with Ansible. First, let me just give you a bit of a background on who am I, because it will kind of come into context here. Yeah, I've been using Ansible. This year marks a decade. First time I used it was actually in a classroom. I first was trying to set the wallpaper to something funny across all the machines, and the problem I faced with all the other tools were very inadequate. So I don't know if any of you have encountered an early attempt called parallel SSH. What it did is you would spawn a terminal and duplicate it across, for example, 10 machines. But if a command returned an error or one, you would be out of drift, because when you would be typing on the keyboard, it would be just duplicating the characters across. So I thought there must be something better, and I found Ansible really quickly after that. And from there, it kind of just started this journey, and I like to joke around that it saved me from probably becoming a front-end developer, which would be a very sad fate. So I'm very happy to have run into Ansible, because it got me interested in Linux and in system administration, and it kind of shaped things for me from there. Currently, I mostly work in the Kubernetes ecosystem, but I still do a lot of Ansible work, mostly consulting around in my spare time from my day job. So that's more or less about me. And now we're going to talk about the plan for this talk, so you know what you'll get out of it. So I'm going to show you a real case from a real customer I've had that I've convinced to open source this, where they needed an installer. And I will give you a bit of background on where it applies, so you know where it might fit your use case, where it might not fit your use case, because it fits a very specific, very niche need. Then I'm going to give you a high-level overview how you interact with it as a user, what you get, the experience that you get, and then we're going to get into the details of how we actually achieve the thing. So, the problem. A while ago, I was working with a startup that's basically based on top of a container platform. So what they need to do is they need to provision a lot of things, they need to configure quite a big stack, but they don't know where they ship. So they have some customers that have 50 machines, for example, they've barely used Linux, and they need to install some solution. I'm being vague just to not distract with the details of it. The point is, we need to ship to some environment. We don't know what we'll get. We don't know what Linux distribution we're getting. We don't know if there's Ansible available. We don't know if we have internet access, which is another fun challenge. So we have to solve for all of this, and this needs to be shippable to customers. So that's essentially how... Oh, I forgot the most important part. Should I run back a short bit?
No,
we're good.
Picked it up, but you can put it on your...
Like that?
Yeah. Take it out the first problem.
Cool. Alright, 1, 2, 1, 2.
Is that the whole? Yeah.
We're good.
There we go.
Alright, so let's carry on. So yeah, that's what we had to solve for, and I'm going to show you around how we did that. So here's how it works. If you're a user, you get a single executable, which has Ansible and all your dependencies. You don't need Ansible in your host system. Your playbooks, your roles, anything you want to deploy, it's inside this. And as a user, you run sudo, my executable, everything's configured. You don't need Python on the host system. You don't need anything. As long as it's a Linux machine, you're good. So first I'm going to show a little bit how it works, just do a short run of it, and then we're going to see inside the tool what it's doing. So I have a machine. Let me open it up real quick and get you a terminal here. Oops. I think I need to unfull screen this first. Right. There we go. Again, you'll have to bear with me using GNOME because this is, yeah. I lost all my fancy keyboard shortcuts and now I don't know where I am. But I'm going to, as I say, show a little demo machine I have. Whoops. Hold on, is the terminal happy? Okay, I think it's covered up by that art prompt, so I'm just going to make a show here. Whoop. Yeah, I hope that's the right one. Okay, I have two of them because we're going to demo some more fun stuff later. So I'm going to go back and fix it real quick. Here we are. Okay, so I have the pre-built thing. After the talk, you'll get a link to the repo where you can build it yourself if you want to. But I tested the build before the talk, and it takes too long to do live because it needs to download a bunch of stuff. So what we're going to do is we're going to run our little self-contained Ansible demo. And for now, what I'll have it do is I'll just have it create some files, copy some things around. So you can see we're in an Ansible playbook now. And it copied some files, copied example.com to /temp. So I can see now I do have example.html. But more importantly, if I check if I have Ansible on this host, I do not. If I check if I have maybe some containers, I do not. So, whoops, what did I do?
Oh, you just got some standard stuff.
Yeah. So there's no Podman, no Docker, nothing like that. No cards up my sleeve, no coins hidden in the sleeves. It's not a magic trick. So this is the user experience. You can do that air-gapped. You can do that in a bunker underground. Obviously, then this install will get quite sizable because it's not magic. It has to carry the files around. So now I'm going to go back to the slides. There we go. And let's bring that back. Full screen. I'm going to just get that closed somehow. Let me just refresh. Oh. Okay. I will quickly.
Some presenter mode.
Yeah. Okay, we're going to go back to where we are. Yeah. So, how this works is this is a tarball. As you might guess, we have to package all the dependencies, including Python, Ansible, the playbooks. All of that is sitting inside a big tarball. And the magic trick that we're performing is Linux has got some ways to get to where the root file system is, as from the perspective of a process. And this is often used in containerization to trick it and say, hey, you're not allowed to go outside of something, but we can also use it unrestricted. And we can, into our tarball, mount PID1, and PID1 sees your file system. So what we're doing is we're unpacking our tarball somewhere, we're putting PID1 inside of it, which is your system's first init process. This has knowledge of your host machine outside the tarball. And then from the tarball's perspective, we're going to use the Ansible Truth plugin. Because Ansible is able to take a file path and say this is a system, and it's able to just go in and run your playbook. And if you notice the playbook execution, once it unpacked, it was pretty fast, because we're not doing SSH connections, so it's a bit faster than usual. We are just going in through prods1 root, and we are able to get at the host machine. So this is essentially how we achieve that, but I'm going to show you just inside the installer so you can get a picture step by step of how we are able to essentially get that there. So I'm going to hop back into a terminal. Whoops. Oh. And we're just going to poke around a live Linux system. So just to get you an idea, so the main thing we're relying on is truth. Truth is I'm saying I'm in this directory. It can be /home/Daniel. and I can say, hey, treat this as the slash at the top of the file system. This is what we're relying on. This is the whole trick that we're abusing. So the trick we're abusing, right? I can make empty here fake fs, right? And if I were to root into fake fs, it doesn't have all the core utils, so it'll get a bit angry at me. But if I were to root into fake fs, I would then be in var from the perspective of the process. Now I'm going to show you from the tarball that we had. It's unpacked here. Ansible fs root. So I can do root this, and you can see I'm in here, right? So this says I'm in slash. So if I do touch slash, I am in an unpacked tar, and you can see this file. But if I exit, so I do exit, you can see it's not here. Well, I'll grab for it because this is not very readable. So there's no unpacked tar. So this is the whole principle we're relying on, just to give you whether we have the common idea of truth. So from here, what Linux does, and what we're abusing, is if I look at any process, I can see from its perspective what is the file system. So all I'm doing is the executable is a self-unpacking tar that mounts this /procs file system, which is not a real file system. It's a virtual file system, which is how Linux presents some ways for you to obtain information about processes. You can also use it to perform certain actions. So this is how many interfaces in Linux work. This is the basis of, for example, C groups. Very identical interface where you can read things to a file, write things to a file, and interact with your Linux machine that way. So if I mount that in, what I essentially will have, and we're going to do that mount now. If I go to fake fs, you see that prods is not a thing. So what I have to do is I have to mount it. Yeah, but there's also a flag you can do. You don't have to bind one. I already heard the idea from there. But what we've got is if I go into the installer, and if I go, I think it's installer.shell. Nope, it's installer.run. My name is horrible. So, what you can tell Linux is say mount that fake file system and create that interface. So this is an interface. So when you make an fopen call on this is not going through normal handling. This is going to the kernel and interfacing directly with it. This is how it's implemented. So it implements the same interface as you would have in your file system to read the file. But instead of going to a file, you're going to a kernel. It's like an API for it. We can think of it the same way. It's like you're kerning the kernel through the file system. It's one way to think about it. So we're going to do this. And I'm going to then show you how the rest of the magic trick fits together. Oops. I did something funny, but okay. Mount /prods. That should be it. Whoops. What did I do?
Destination.
Hold on. Got it. Ah, yeah. Gotcha.
Well, you've got the destination, that's all.
Yeah. /prods and prods. There we go.
You need to make the directory first.
Ah, yeah. Live demos. Good idea. There you go. So, if we go into prods, you can see also all the processes running on my system. So those numbers here were PIDs. So this is what we're abusing with Ansible, because we're telling Ansible, hey, from the perspective of process 1, which is your host system, you can see here, if I do ls prods, actually let me root again so that you see it from really Ansible's perspective. So now we're going in to fake fs. So this is what Ansible sees. Oop. What did I do? Ah, no, it's not fake fs, it's, oh, goddammit. It's Ansible fs root. Sorry about that. Root. There we go. So in here, if I go ls prods 1 root, this is my root files. Well, my bad. Typing funny. So this is the root file system of my machine. This is where I'm targeting. This is where Ansible is getting at. And in this tarball, before remember I ran where is Ansible, I didn't get an answer. Whoop, I don't have which one here.
Try type.
Yeah.
Type Ansible.
Type Ansible. There we go.
That's in the shell. Yeah. So shell built in.
Yeah. Well, there we go. So, I have Ansible in my tarball. I can execute Ansible in here. Even if my customer has a weird setup, and this is a case we've hit, we had a place where somebody had a weird version of Ansible where everything had broken. I don't have to worry about it because I'm not affected by that version of Ansible. If somebody's running Python 2.7 for whatever reason still, I don't worry about it. I have my own Python. So this is really a way you can think of having an installer that's kind of very in the style of Windows MSI installers. We have one file, it has everything it needs, it unpacks itself, it installs things, and you don't need to worry about what's on the other end. So this is for if you're shipping some obscure big software, or if you're shipping a small game with some dependencies and you want to do some sanity checks. This is very much in this kind of old school installer sense. This is not a package you would place on a network. This is not something you automate a bunch of hosts with. This is more coming back to the idea of, I'm a kid, I went to the store, I got a CD with a game, I want to install it, and how do I make an installer for that game with Ansible? This is more this kind of old school installer in that sense. So yeah, this is the trick we're using, and from there, you can see here, I have an installer directory where I simply have all my files, and I have my installer playbook, and you can see it's just doing a bunch of stuff. Please zoom out a bit, or maybe just do less. Let's see if we have less on this tarball. Yeah, we have it. So this is just a bunch of Ansible code. I'm asserting things, I'm running things, but it's a very standard playbook. The magic is more in the inventory. So if I go to the top, you see I have hosts, truth targets, and connection truth. And this is, this is built into Ansible. This is how Ansible is able to go to any directory and execute those commands. I didn't have to do any extra legwork on it. The tool has it. And the inventory, here it is. If you've been noticing what we have in +1 root, +1 root is the inventory. So this is the whole how we trick Ansible into running from our own packaging, and this is how we get essentially the installer to work to target the whole system. We're escaping out of the truth. This is also, if you're interested in containers, why there are some very, very specific constraints you need to place around pointing your container to a different file system, because people try to get out. We abuse it for our purposes, but in container systems, people have to do a lot of legwork to prevent it. They actually have a different call to do a bit of a fancier truth. They call it pivot root. But this is an aside. For us, we want the least secure one because we want to break it. So this is how we do that. Let me check how we're on time. We're very good, I think. So I'm going to show you around one other interesting thing, which is there was an extra constraint I didn't mention, which is the platform I built this for, the customer that needed this. They actually run on top of a container platform. So they provision more nodes. So this is how they provision their first node in the cluster. And now the next challenge is, well, I want to provision additional 10 nodes from some web UI that my platform has. So what they wanted to have is have the same base for their execution environment. If you're familiar with AWX or Ansible Tower, this is the terminology for the container where you run your playbooks. And the same environment for this little tower. So instead of having two different steps to derive a tower file where Ansible can run, this is actually directly derived from a valid execution environment. So what I am doing here is I have, let's go back to the repo. I'll go back to bash so the R prompt doesn't look funny. So in the container file, I'm actually doing an OCI build. Let me make it scrollable. Container file. There we go. So this is a standard OCI build, but as you might have noticed, we didn't use any OCI tooling. So this is how we define what the tarball will be. But because I don't want to increase people's S-bombs because I have a lot of those environments, like I mentioned, people ship it somewhere underground without internet. That means they have regulatory restrictions. If they have regulatory restrictions, anything I ask them to put ahead of the install on the system, they need to patch it. So if I say, hey, I want Docker for my installer to run, I have more problems. So even though I like the OCI format and I want to put in the OCI format, this whole thing builds a container image, but we do not use a container image. What we're doing? Yeah, we are unpacking it with, I have a little build tar thing. I think that's, sorry, there's, yeah, build tar should be it. So what we're doing is we are unpacking the whole thing. What you have here is two little utilities that work with OCI, and what we're doing is we're taking all the layers of the image, we get it into a place, and from there we assemble it into a normal file system. And from there we have a tar file, and this tar file becomes the target of our truth. So what this does is it essentially allows me to say, hey, I have an execution environment that I can run on AWS, I can run with all of standard Ansible tooling, I can run it if I want to exec into it directly, doesn't matter, but I also have a tarball that doesn't depend on any container runtime. So that is the rationale behind this. And from there, what I do is I have a very simple script that says build shell archive .shell. And what it does is essentially, you see there's a little demarcation tar payload below, which means I have a script at the top. The script looks at the file, so that the very executable that I'm running is going to run through, and it's going to then read itself from tar payload below. And it's going to move that into a separate file and unpack itself. So I simply have a script at the top of the file, and then everything below this demarcation is my giant tar. And that is how you can make a self-extracting tar archive. This is the whole idea behind it. And that is essentially what we're doing. I can show you also the extraction logic. I think we'll be in the scripts run installer, this guy. Oh, I think we're in the directory actually. Whoops, I did something. Run installer.shell. And oops, that's the wrong gap. So run installer.shell. So it does a bunch of stuff like cleaning up the mount points, mounting them the correct way. This will be made available after the talk so you can have a look around. Essentially, it makes sure you're safe. For example, if you bind mount over your dev directory twice, all your PTYs die, you have to reboot your machine, not a good time. So I've got some safeties here, but just make sure that doesn't happen. But the thing that we're really interested in is, this is the guy, this is how we do the extraction, right? We just match on that line we had in there. So we just say, hey, here's the tar payload, it's below this line, take everything, pass it to tar, and we just extract the file system. So this is the core of how the installer is built. And whoops. And from here, let's go back to this. One thing I want to mention is a couple of other patterns you could use in here. One thing I tried early on, so this wasn't my first attempt, I've messed it up a couple times first. I've tried tar utils. It removes the tar dependency. It's actually, you don't need tar on your system at all, but it is trickier to work with. I just ran into a couple issues getting it to unpack cleanly and then execute. So tar utils, it took a bit of fighting, so I just decided to simplify it and just use this little demarcation line you've seen. There are a couple of projects that aim to package CRUN, which is for those of you less in the container space. What this is a container runtime. That was actually my first attempt because I had OCI, so I thought if I can prepend a container runtime to the executable, maybe this could work. There is a few projects that make it in a way that they build a single executable for you that ships, but they have problems mounting directories in and essentially getting proc1 root mounted. was very tricky. And I got it working at one point, but I had to patch a bunch of weird custom Zig code, and that was the point where I decided this might not be friendly to people. So that was, there's a couple of things that if they come to your mind, probably a bit tricky to work with, and a bit of a pain. One thing I wanted to do is give a shout out to Juno Innovations, because in that repo, so that repo is just an isolated example for you to be able to look around, see how it works, verify it, you can play with it. But in the same repo, I link to a real CI that releases this. Their stuff is also open source, so you can see how a full container platform makes automated releases in the CI, how they do all of that. So on their GitHub, there will be links to it. We'll be able to find some references for some more production-ready way to solve this. So yeah, big shout out to Juno. They do really cool stuff. If you like VDI and custom environments on Kubernetes, which you can click around with, cool folk. And I've got another demo in case we've got time, but first I want to run through Q&A because it really does the same stuff, but it just shows how those get fed in the real world. So I'd first like to do the Q&A, ask as many questions as you'd like, and then if we still have time, we can look at the other stuff, but you won't get anything new out of it, it's just shiny. Cool, shoot.
Okay, question. Do you know PEX, Python executable? So it's a wrapper over the Python's code, so you don't have to...
Is it similar to how I think there was a project called PyInstaller, where you make a single executable Python?
Yes, I mean that.
Yeah.
But it does not include the Python.
Sure?
PEX does not include the Python executable. PyInstaller does.
Okay.
But to answer in that context of if I looked at the things that package just Python, I only looked very briefly because the other constraint was it was a must-have to have that OCI image. The reason for it is the platform that customer spawns, it's a Kubernetes platform, as is in fashion today. And what happens is once you run this installer, you get their platform, you go into the web UI, and then you spawn containers to join your other nodes. It's kind of like Portman's AWX, just to get your other nodes joined. So that's why I discarded that earlier. It just, for them, it didn't make sense. They really needed that shared container. So yeah, any more questions? Sure.
I wanted to ask you if you basically use the change root and mount the proc1 file system. Are there any race conditions to consider? Is there any interference with the file system of the actual root, or if the installation happens in parallel? So maybe.
No, there's no problem. So.
Excuse me, Daniel, can you repeat the question
yeah.
so that it gets.
Yeah, my bad. So the question was if there's any interference from mounting /procs. So because all we do is we just run the Ansible playbook process and nothing else inside, there's nothing to mess with it in any way. So this is not, another Linux host. This is just to run this one process. It's very similar to, for example, if you run a privileged Docker container, it's exactly the same thing. Yeah, we just run it, but I do clean the mount points up afterwards, and if you abuse that pattern too, that's pretty important to do because /dev is more sensitive, and I did break my test VM a couple of times well, not break, but I had to reboot it by being a bit too playful with it. So you want to watch out to not mount over /dev twice. That's the trick. Cool.
You use /proc/root, no /1/root for your inventory.
Yes, I use /1/root.
Yeah, but I don't see how that can be an inventory.
So
There is no inventory valid syntax in that.
It's a module.
So the question was on the inventory syntax, if you can just use /1/root. The truth plugin takes that in. So there's a truth execution plugin for Ansible, and it works. The code was built from the same source.
CHU connection plugin.
So essentially what Ansible is doing...
Was that in the Ansible config? That was in the playbook. Oh, okay, I missed that.
Yeah, so what Ansible is
Do
configured...
that again, please.
Yeah, I can show it. So, what we got... Oops. Oh, sorry, I hit the wrong shortcut. Here we go.
Chatting with the organizer.
Oops. Here we are. So, we've got the installer. Oh, let me just do it through less so we can navigate. Play from VI. Installer, play boot to YAML. And in here you can see we have host is true target, connection truth. This is essentially telling it, hey, use the truth plugin that Ansible has built in. How it works under the hood, I have no idea. The fine folk at Ansible have done a really good job, and it just worked first try. So I was very delighted to find it. And the inventory. Oops.
So you can run Ansible inventory.
Oh, I should be able to. Yes. Yeah. There you go. True targets plus one root. So in theory, you could have multiple, but I don't know why we would. But you can. Yeah. Does anyone have any other questions? Sure.
Do you have any concerns about libc or kernel compatibility?
Not really. Anything modern enough will work. The only distinction is we have to do multi-architecture builds if we want to handle ARM. So this is a bit of a pain. In case any of you run into a use case for it, also feel free to ping me after the talk. I've got some tooling that I experimented with, and I can share with you what worked. For this particular installer at the moment is AMD64 only, and the one referenced in the customer case. They also, their platform, the way they ship it, they do have multi-image builds. So if you're interested in that, we can also chat later. And I think somebody else had a question? Yeah?
So the question is, do we really have to rebuild all the things if we already have a container runtime on the system?
But we do not have a container runtime to start with. So the question was, do we need to really package it in the entire if there's a container runtime? And the answer is, this is what all we're guaranteed is Linux. We are not guaranteed Podman, we are not guaranteed Docker, we are not guaranteed any sort of libraries or anything to manage containers. So unfortunately it has to be that way, because the primary use case was actually installing K3s. So that's where that comes from.
If I want to make my own, where do I find documentation and all this stuff? Was that or?
No. So there is a more. So Juno obviously doesn't document it as much because we just do it for our releases. But for this, there's documentation how to use it, not how to build it. For documentation how to build it, you go to. It's linked in the talk, but let me also open it up.
It's okay. It's in the talk.
Yeah, it's linked in the talk. You go to config management camp. You find this talk. You have it in the talk description. I will make the repo public actually right after we finish. And you've got all this, the make file, where you can just run make build and builds. What's up?
You said that you're running this on the air-gapped environments. What about the SBOM and all this security stuff, like software bill of materials, signs, images, and so on?
In air-gapped environments, this we just use it to get K3s in. So essentially they use it as an installer, and then all they have to track is K3s. From there it usually comes under management of some other tools. Also for most of actual air-gapped customers, they have their own methods of running Ansible, so they will usually opt for that. This is more just an option for a very rare case where somebody requests it. But to be honest, most of the time all they care is that it runs offline. Actually the ones who have been pickier about what ships with it were the online ones. Weird mix, but okay, whatever people have running the wilds and whatever constraints they have. Cool, so does anybody else want to ask something? Yeah?
You try to, because you say that you're testing it on the Kubernetes to set up Kubernetes. You try to run it in an OpenShift?
No, we only support K3s on this. So the long story short is the platform this is built for, they sit on top of Kubernetes.
Yeah.
They don't really care which Kubernetes distribution it is, but they have some customers that are not Kubernetes experienced, right? So they need some way to enable them to ship this. Because their core business doesn't concern itself with Kubernetes. Kubernetes is just a tool. So this is for those customers who, let's say, you have a lot of classic data science environments.
Yeah.
They just want something to run, install it, and be done. And they don't necessarily have the in-house resources and bandwidth to be looking now at deploying a Kubernetes cluster. So this is for those people. But that's one of the reasons why this is so structured so that certain components are detached, because for the more advanced customers who may wish to run their own playbooks and apply this from AWS, the repo that Juno Innovations has, it provides it for them built in. So you can skip this installer and go straight to playbooks too, where they basically give them options, and that was kind of the idea here. Cool. Oh, yeah?
Just the last question regarding the methodology. If you have a customer who is asking for an Ansible installation after they provide the Linux box, I don't think with any images to be pre-built that with some sort of like packer or something.
Sorry, can you repeat?
If you have this use case, for example, that you have to run in a very restricted environment in Ansible, where you need to ship all your dependencies, the modules, and the code and whatever, why does this customer not go for a customization of the operating system instead with some tools from HashiCorp like Packer or something?
So that's a good question, but for the clients of this, so the way this the customer I built it for, they just provide a product, and people come to them and they say, hey, we got this, we want an installer. So essentially you can think of them as they don't do integration work with their customers. They just sell a piece of software like self-hosted GitLab would be like this kind of thing, right? So they're a self-hosted infrastructure platform, but they do not interface with the customers that much. All they can do is provide an installer, but they don't advise them on their Kubernetes setup. That is the concern of whoever is on the other end, and they can run whatever Kubernetes distribution they can. So I agree with you. That's how I'd solve it if I was the receiving end on the far end, the end user. But we cannot cover that many end users with, we would have to cover too many cases. So this is just a case of it works for the most people. The other ones say we need to do something custom. But the core thing is this is not their core business, right? So like this installer is just a convenience thing. The actual business that runs this, they assume Kubernetes is provided. So this is something where you can get a POC running with one executable, for example. This is this kind of field we're looking at. Cool. So, unless anybody has other questions, how are we on time?
We have a lot of time.
We have a lot of time.
Yes.
10 minutes left.
Cool. Then what we can try is we can try to do an actual full demo of how this thing looks in the real world. So what we're going to do is we're going to actually go to some upstream documentation. There we go, Juno Innovations Quick Start. So this is the customer I built it for, and they have a curl into bash, our favorite pattern, somewhere here.
Oh, yeah.
That's the root.
Of course.
You mean curl by
Yeah.
by
Yeah, but, yeah.
sudo
By
bash
the
install that
Yeah, that one.
There we go.
Oh yeah.
Everybody's favorite. That's why we also provide the Ansible playbook. So essentially, first we wanted to avoid this, but so many people asked for it, and we were like, fine, it's an
I
option.
love those.
Yes.
And don't download them first to have a look at it. No, don't do that. YOLO.
YOLO, indeed. So let's go on that note. Whoops. Here we are. I think I'm still in the root. Oh no, I'm here. Okay, let's SSH in. And we are going to do this. And we are going to do something like, the product's name is Orion, so we're going to orion.config mgmt, and I'm just going to put that in my host file. Let me do it real quick, because the thing will need that. Oops, what did I do? Okay. And I will check the IP in a second. Okay, so this is our name of our thing. We can do example.com. And the password will be super secret. Oh, yeah.
That's fine, that's just fine.
Letters only. So I can't have example one.
Question when do you need to enter password before user
AI building. It's alphabetical.
No, it's not. It's temporary. TU, yeah. TU.
Then we are going to do on-prem K3s. And then, oops, that's the one. So, yeah, this is our interactive installer. And you can see this is downloading that tarball we were talking about earlier. And it's going to get us all set up. In the meantime, let me check the IP of this box. We are on... I cannot see.
8.9 something is that.
Yeah, let me check. Oops. I think it was... Yeah, it should be that one. So...
You should have made this beforehand.
I had it pre-made, but bridging the VLAN, I had it on local VMs, but it didn't quite work.
Yeah, you changed it on the fly.
Yeah, so this is how you should do all your demos prepared on last minute.
Yeah. Oh yeah, we know.
Yeah. Wait, where was I?
Request for next year. That WireGuard works through the Wi-Fi.
Oh yeah, I really want WireGuard to work to the Wi-Fi.
Yeah, there we are. WQ. Okay. You can see. I mean, the installer is downloading stuff now, so this is good. Go on.
It's crooked. It's not fun.
There we go.
Cool. Okay. Now, this is still downloading.
Yeah.
So we'll see how it goes.
How large is? Do you know how large it is?
I haven't worked with the customer for a while. I just caught up with them over beer, but they might have shipped some. So we'll see. I tested it, but I tested it on pretty fast internet.
Yeah, exactly. Wi-Fi isn't fast here.
Yeah, but this is not a...
No, this is a
This
customer.
is a machine on the internet, right?
Yeah, this is.
Oh, okay.
If this is stuff, and we can blame German hosting providers. It's okay.
That's not.
Yeah.
You have all the whole K3s in this tarball?
Jesus
Jesus Christ.
No, but K3s is very large, right? It's like 50 or 60 megs. But the most...
That's a
Yeah,
single
but
go
the
by.
dependency, depending on what do you want to add, so it's kind of...
But the whole core idea of K3s is actually to be a single executable.
Yeah.
But the problem is a lot of the Ansible collections, I think I didn't clean out most of them yet. I have that somewhere on the to-do. When you build this, it's very good to go in with something like NCDU. So NCDU is a tool to visually see your file system, poke around and see what takes up the most space. So you can then add cleanup statements and just remove unnecessary bloat from your image. But yeah, we'll see how fast this goes, but this is...
You have this is OCI image, you can use dive. So if this is an OCI image, you can use dive to analyze the layers.
That's a good idea, because does it also do minimizing, or is it just...
This is just for analyzing the size of the layers, the dependencies, so you can see what's going on. And you can give you more details, you can do, for example, the compression rate.
And sorry, I forgot about the online again. The question was about Dive, which apparently is a really good tool to check out for minimizing the images. But yeah, I think we might have just gotten bit by either my connection hanging or something happened at Hessner. Let's see. Oh,
It's doing stuff.
It is working.
yeah, let's see.
Install ATOM.
Copy trap.
Run for a commercial.
Yeah, we can see what it's doing. Installer. I think
Is it the same box?
should be. Wait, 1-1.
Yeah, well,
We don't see it.
scroll up.
But I can scroll up. I'm missing all my keybinds. I'm sorry. I'm a very confused Kitty user trying to use GNOME terminal.
Little up.
A little up, a little up.
Little
Yeah.
Let's stop. L11.
1-1. Yeah. Okay.
It's doing stuff. What
You could try just curl head the Juno tarball.
Yeah, search for
See
curl.
the size.
Yeah. Could search for it.
The next option will be curl progress.
Yeah. Okay.
So it's from
Progress
different.
would be.
yeah, it's on a GitHub release. Are we still good on time? We can, if we got more questions, we can also grab them.
Type date. Type date for time.
Yeah.
Because if you type time for time, then you get something to do.
So we had a use case similar to this, and but we said to the customers, because they said they have air-gapped environments, and they say the only thing that I can accept is OCI images, a long time ago Docker images. So that we packed everything in a container and we were running Ansible inside, and actually one of the steps was also uploading our images to their registry. So a lot of it was like recreating. So the only thing that we needed to is the name of the namespace they wanted to install the application, the registry address and credentials and specific service account in Kubernetes cluster to all the stuff. Long story short, 45 minutes and we had all this stuff for the AI and shiny things.
Okay, cool. I'll repeat it again for the online people because I'm trying to be on my best behavior. So somebody actually had a really good, really clever way to do it, which is to packet the images and upload them to the local registry as a step. To be honest, I haven't followed that. I was just using mirrors all the time. So to the installer, if you do the offline configuration, you can tell it, here's my local OCI registry, and it's a mirror. So that was how I was solving it. But it's also really, really slick idea. I like it to package the images and upload them in. So cool, really cool. Yeah, I think this will run forever, unfortunately. I think I have a head start to blame. On AWS it was fast, and on my local Wi-Fi at home it was fast too. But here I think we're just going to stare at it. So unfortunately, one of the two live demos worked. This one, if you're interested in seeing how this looks in a VDI platform, I can show you their documentation. They have a screenshot, but that's the last glimpse of Ansible will catch. So the same playbook, just so that you get an idea of what the next step is they have a thing. Whoops, I think it's I think it's joining nodes to your cluster. Yes, joining nodes to your cluster. And in here, I think there will be a screenshot. No.
What's new effects?
So those guys what we're building is a platform. That's not it. It's a platform for essentially where you have multiple environments. Like you have an environment for one team of data scientists. They have some storage containerized, and they spawn Jupyter notebooks. You have another team. You have people with VDI and, for example, VS Code instances embedded in the browser. So this is what the platform does.
But we expand cluster, bottom left.
Oh, bottom left. Yeah, thank you so much. On-premise. Yeah, there we are. And yes, so I even did a thing. So this is how it would look like if Headstone Internet wasn't doing something funny. But essentially it's performance AWX. The backend I've written for it is essentially a task runner. But that part, unfortunately, is outside of the public repos. But if you want to see how everything up to this stage builds up, for a simple version, check out the links in the talk. For in production, real world people doing it. Those guys also have it open source. Check out github.com/juno-effects. And I think we can wrap it up here. Thank you guys so much for coming, and I hope some of it was useful.